This example is starting us off with what appears at first to be a limit problem. They're asking us to find the answer to this limit, and I guess technically it is, but that finding it as a standard limit is really not the method we're going to end up using here. So this would be limit as h approaches 0. And one of the best things you can do for yourself when you're putting this stuff together, I don't know why they don't put things in parentheses like they ought to. Just when it's e to a power, and whatever that power is, you would kind of want to think about it in parentheses, minus e, and then again to a power here up top. So I always add in those parentheses. They do it with e's, they do it with logs, they do it with trig functions. I don't know why they don't put the parentheses there, but a little bit of parentheses will kind of help you see a lot about what's going on with these types of problems. So that's what we're being asked to find the limit of. The secret to this problem, though, is it's really not a limit problem. It's a derivative problem. And one of the best ways you can tell that is by this little piece right here, limit as h approaches 0. The only time we really find the limit as h approaches 0 in this AP Calc class is when we're talking about that limit definition of the derivative. And that's what we need to apply here. So let's pull out of our brains what the limit definition of the derivative. So this is the limit definition at a specific point, so x naught. So f prime of x naught is equal to the limit as h approaches 0 of f of x plus h, or f of x naught plus h, minus f of x naught all over h. And so now what we want to do is we got to kind of try to transfer our knowledge of this limit definition of the derivative to the specific problem we're looking at. First things first is you kind of notice that we've got this x plus h, and that looks really similar to this negative 2 minus h. And then we got this x naught here, and again, seems to be matching up. We can kind of see that there's like a similar value going on in both of those pieces. The main difference right now in our problem is we've got plus going down here. So this is x naught plus h happening here, whereas up in the original equation, they've got a minus on our h. So the first move you would want to do on this is let's try to make it look even more like that limit definition by getting that to be a plus. Well, to get that to be a plus, what you need to do is you're going to factor a negative out of everything. So this would be negative. And then now you'd have pulling the negative out of that negative 2 would give us a positive 2, and then that will be a plus h minus, and then you're going to kind of want to pull the same move on the other side here because you want these things to look similar. So I pull a negative to the front, and then that negative 2 becomes a positive 2 all over h. So now that we've done that, now we can see that we're getting the match that we like. I've got x naught plus h. There's that x naught plus h, and there's that x naught sitting at the back end right there. So how does that relate to this limit definition? Well, let's try putting it together. So this would have been f prime of, and what would our x naught value have been? What would that value have been in this problem? That would have been a 2. So f prime of 2. Well, what's the function? What are we plugging it into? And you can see here that whatever you plug this x naught plus h into, and whatever you plug this x naught into, that is your f function. So for us right now, our f of x in this situation is going to equal e, not just to the x, we pulled that negative to the front. This is going to equal e to the negative x, because that's what we're plugging in this x naught plus h into and plugging that x naught into. So in the end here, now what we have is we've got the function that we need to take the derivative of, and in the end we'll plug in that value of 2. So we'll come over and take care of that derivative. So if f of x equals e to the negative x, to find the derivative of that, this is what I refer to as a special case derivative. E is one of those derivatives that you just have to know by looking at it. So if f of x equals e to the x, the derivative of e to the x is e to the x. However, if what's inside that e right there is anything more than just a basic x, negative x, say, like we're looking at right now, 3x, as soon as it's more than just an x inside there, it's a chain rule problem. And so to find our derivative right now, we're actually going to need to go apply the chain rule. So my chain rule recipe, my chain rule saying that I use goes d in times d out, the derivative of whatever got plugged into that function times the derivative of the outside, which follows this rule. So here my inside piece is negative x. So f prime of x would equal, if we just kind of pulled that off to the side and said, how do I take the derivative of negative x? Well, we would follow our power rule. There's an unwritten 1 right there. You'd bring the 1 down. That would get you negative 1. Technically, you would get x to the 0, but anything to the 0 power is 1, and so you don't ever write that. You don't need negative 1 times 1. So the derivative of our in would be negative 1. And then the derivative of the outside on an e just, again, follows this rule. It stays the exact same, e to the negative x. So we now have our derivative, and from there we're going to go ahead and plug in the value that we were looking at. So this is f prime of 2. So we come in, this would be negative 1 times e to the negative 2, replacing x with the 2. That's our answer. If you look up above, you don't necessarily see your answer to begin with. And so we got to look to do some sort of algebraic rewrites. And what you're going to see here is when you've got anything to a negative power, that's a rewrite. Normally, we're used to using that rewrite in the other direction. Whenever you've got a number over x to a power, right, before you took a derivative, you always rewrote that by bringing the power up to the top and making it negative. So if it was 5 over x to the third, you'd rewrite that as 5x to the negative 3. Well, here we're going to undo that rewrite. We're basically starting with the negative power, and we just want to put that back down to the bottom. So for us, f prime of 2, the negative 1's going to stay on top, and then we're going to rewrite that, putting that back down to the bottom here. This would be e squared now. And that is an answer that we can find up above. That's option C. So remember, when you see limit as h approaches 0, 99 times out of 100, that's really coming back to your limit definition of the derivative, and you got to be able to work from that to be able to find your f of x and find the value you're plugging in, because this really isn't a limit problem, it's a derivative problem. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.